Hi, this is the octagon in the parallelogram area problem. We are given that the point P, Q, R, S are the midpoints of the sides of the parallelogram. And the area of the parallelogram equals to 1. We want to find the area of the octagon. All right. Well, before we can solve the problem, let's do some basic construction. And that is the midpoint P, and that is the midpoint R. We're going to connect these 2 points here, and connect these 2 points. All right. Now, these 2 are parallel. That means this angle and that angle are the same, are congruent. These 2 are congruent as well. And these 2 segments are congruent. That means these 2 triangles are congruent by angle side angle. And these 2 segments are congruent, and these 2 segments are congruent as well. Do the same thing on the other side. We'll connect these 2 points. And these 2 points as well. And now I have 4 congruent triangles, 1, 2, 3, 4. And I'm going to connect these 2 points here. And make a segment. Now, since they have the same height, that means this line segment must be parallel to these 2 sides. And these 2 triangles are congruent, are similar. So that is 1 to 2. So this one will be 1 to 2 as well. So that is the midpoint Q. The same idea. So that is the midpoint S. I'm going to connect P to R. And look at these 2 triangles here. The triangle on the top and the big triangle here. They are similar triangles. Well, the ratio is 1 to 2. So the ratio here is also 1 to 2. If I call this x, this one will be 2x. If this is 2x, this one will be x. So the same thing over here, it is x and x. Well, I'm going to do the same thing on the top. I'm going to connect these 2 points. Connect these 2 points. Do the same thing at the bottom. Well, using the same idea, we can say that that is y. These 4 segments here are congruent, so y unit, y unit, y unit, and y unit here. Now we are ready to solve the problem. And here we go. All right. This is the original diagram for the problem, and we're going to put in the additional lines here, here. I'm going to connect the main diagonals. right? Now remember from our discussion, these four segments here, 1, 2, 3, 4, they are congruent. And also these four segments here are congruent. And now we want to find the area of this octagon. Well, here we go. And the octagon have been divided into 8 smaller triangles here. Let me call this triangle with area A. This triangle here with area A. And this triangle here will have the same area. The reason is quite simple. They have the same base, same height. So the area must be the same. I want you to look at this triangle here. Let me connect these 2 points. Look at this triangle here. From this point to the midpoint of the opposite side. From this point to the midpoint of the opposite side. So these two are actually the medians. And this one will be the centroid. And the centroid will divide the median in the ratio of 2 to 1. So that is 2 to 1. 2 to 1. And this area, the triangle of this area must be A. It's quite simple. The base is 2 to 1 and they have the same height. So the area must be 2 times as large as this one. 2 to 1. 2A and 1A. And we can do the same thing on the other smaller parallelograms here. If I call this small b, the triangle with small b area, and this one will be small b as well. Same base, same height. And now again, this is the centroid. That is the median, and the ratio is 2 to 1 again, 2 to 1. So 2b here, and this one will be b. The same thing over here. Let's say we call that C. The area of this triangle is C, and this one will be C as well. Same base, same height. This is the centroid. The ratio is 2 to 1, so this one must be C. The same idea over here. If I call this one D, the area of this triangle is D, this one will be D. Same base, same height. Centroid again. So 2 to 1, so this one must be D. And now, take a look at this triangle here. This triangle is 1/4 of this small parallelogram. And this small parallelogram is 1/4 of the big parallelogram. So 3A, when we combine the 3 triangles here, we have 3A equals to 1/4 times 1/4 of the big parallelogram here. So we have 3A equals to 1 over 16, and A equals to 1 over 48. But the same thing for B and C and D. So A equals to B, equals to C, equals to D, equals to 1 over 48. All right? So the area of the octagon equals to A times A, because we have A of them. A times the area of A, which is A times 1 over 48, which is 1/6. So the octagon is actually 1/6 of the parallelogram. And I think we are done here. and thank you for watching.